Alright, welcome everyone. So this is a worksheet that I have prepared by compiling paper 2 questions of O-level physics for the chapter of current electricity, and there are about 8 questions that we will go through. So let's get going. Question number 1 says that there are 3 cells and they're all connected in series. The EMF of each cell is 1.5 volts and the resistor is of 15 ohms, which is connected across the battery. So the first part is asking about the total EMF of the battery. Well, if each of the cells have an EMF of 1.5 volts, all you need to do is add them together. So 1.5 plus 1.5 plus 1.5 should give us 4.5 volts. What is the second question? Calculate the current in the circuit. So now we have to calculate the current, and if you remember, the simple equation that we use for this particular task is I equals V over R. So what is the potential difference across this resistor? Well, obviously this is going to be 4.5 volts, which is the EMF of the battery, and then we have the resistance as 15 ohms. So all we need to do is 4.5 divided by 15 ohms, and that should give us 0.3 amperes. So we'll write down an answer with the units. The units are really important. Now they are using the same 3 cells, but this time they are connected in parallel. So they're asking what is one advantage of connecting the cells in parallel. Now if you look at the number of lines, you might think that you have to write a very long answer, but the first thing that you should really look at is the number of marks, which are only 1. The second thing that you should focus on is that the command word here is state. So you don't really have to write a very detailed answer. In fact, the answer has to be short and sweet, and we don't have to give any reasons for those answers. So there are basically 2 advantages that we mostly learn in O levels for the cells in parallel. One of them is that cells last longer. Now the reason behind that is that the current flowing through each cell is smaller, but we don't need to write that reason. Another reason that you could have written, which you don't need to write in order to get 1 out of 1, is that if one cell stops working, the others keep working. So pretty simple question. Now we are on to question number 2, and they're saying that a filament lamp is labeled these 2 values. The voltage of the lamp should be 240 and the current passing through it should be 0.2 amperes. Now when they use vocabulary like labeled, or they might use the word here rated for anything, that basically tells you that these values should be given to the bulb. It should have a potential difference of 240 volt and a current of 0.2 amperes passing through it if it is to be working at normal brightness. So right now in part A, the lamp is working at normal brightness. So what would be the resistance of the lamp? Well, again we will use the same equation, but this time I'm rearranging it for the resistance, and that would be V over I. So if it is working at normal brightness, then the voltage across it is 240 and the current passing through it is 0.2. So the resistance should be 1200 ohms. Part B says that the lamp is connected to a 240 volt supply, so that would be the potential difference across it, and it is switched on at time t equals 0. And then there's a graph given to us, which is time on the x-axis, and then there is resistance on the y-axis. Now in your books and in your notes or in your class, you wouldn't really come across this graph, but it's not really hard to understand. The graph is simply telling you that initially the resistance of the lamp increases, and then after some times the resistance is steady. And what they are asking you is to relate this graph to the current and say how the current varies. So how the current varies? in accordance with resistance? Well, it's pretty simple. If resistance is increasing, when resistance is increasing, what should happen to the current? The current will decrease, and later on, when the resistance is steady, so it's no longer increasing, then the current will stop decreasing as well. So the current will be constant, and we know this because of the relationship that I equals V over R. Now if your V is constant, which means the V is not changing, but your R is increasing, then the current should decrease. If R, let's say, is decreasing, then the current must increase. The current and the resistance will be inversely proportional to each other if the voltage across the component is kept constant. So this was part B. Now let's move on to part C, which says that there is a second filament which has a higher resistance. So we have to state two differences between the two filaments that may cause this change in resistance. So how can you make the resistance of the lamp higher? Well, there are actually four things that can make the resistance higher of anything. Number one is length, right? Number two is cross-sectional area. Number three is material. The type of material, the choice of material can also increase or decrease the resistance. And number four is temperature. So we only have to write two out of these four things, any two that you like, but you must remember what is the relationship of resistance with each of these things. So for length, the resistance is directly proportional to it. So if length is increasing, the resistance will also increase. Whereas with cross-sectional area, the resistance is actually inversely proportional. So if a wire is thicker, which means it has a higher, more cross-sectional area, it has a bigger diameter, then the resistance is going to decrease. So we can't write that the second lamp is going to have a larger area. In fact, we should write it has a smaller area if we are going to write that one. Then the material has a property called resistivity. So good conductors have a low resistance or low resistivity. So if you want to write the third point, you would mention that the filament is made from another material with higher resistivity, so that it has a higher resistance. Or you could also say that the temperature of the filament is higher, therefore the resistance of the lamp is higher. So with temperature, the resistance also increases. So we are just going to write the first 2 points, where I'm going to say that the filament in the second lamp is longer, which is to say it has more length, so that means it will have more resistance. And for the second point, I'm going to say it is thinner. So if it is thinner, that means it has less cross-sectional area, which means it will have a greater resistance. Alright, let's move on to question number 3. Now this is the experiment which you basically do in order to get a bunch of readings for current and potential difference across a component. In this case, we are using a lamp, and what this circuit is going to do, it is going to allow us to get many different values for the current and the voltage for the bulb, and that can basically help us draw a graph of V versus I or I versus V, and that can help us understand how the current and the voltage are related to each other in a certain component. So you could have you could replace the bulb with anything else. You could replace it with a diode, you can replace it with a thermistor, you could replace it with a simple resistor, and see how the current and the voltage are related to each other in any component. And how do we make the adjustment? Well, this thing right here is called a rheostat or a variable resistor. You adjust the resistance of this variable resistor, and then it allows you, that basically adjusts the voltage across the bulb, and then also affects the value of the current. So each time you make an adjustment, you take a new value for the voltage and the current, and that basically helps you get a bunch of different values. Alright, so let's start attempting this question. first thing that they're asking us is what is the name of this component P. So as just mentioned, either you will just call it a variable resistor, or you could also call it a rheostat. Okay. Part B saying on the axis below sketch a graph of current against PD. So current is on the y-axis and potential difference, the voltage, is on the x-axis. Now you are supposed to remember the shape of the current versus voltage graph for three things. Number one is a metallic conductor which is at constant temperature. Number two is a lamp, the filament lamp, which we have to draw right now. And number three is a diode. These are the three things for which you must remember the shape of their graphs, and you must be able to describe the reasons behind the shape of those graphs. So in this particular case, the shape basically looks like this. So it's basically a curve with a decreasing gradient, and many students have a difficult time understanding the meaning of this word gradient. Well, an alternative word for this gradient is slope. So the slope of the line is decreasing, which is to say that the line is steeper in this region, and then it is less steep, and then it's less steep, less steep, less steep, and as you keep moving forward, the line gets flatter and flatter. So the slope is decreasing, right? Now they're saying state how the resistance of the lamp changes as PD increases. So as potential difference is increasing, what can we say about the resistance, whether the resistance is constant, whether it's increasing or it's decreasing? Well, you must remember that for this kind of graph, the gradient is basically inversely proportional to the resistance. So if the gradient of the graph is decreasing, then I can clearly see that the resistance of the lamp must be increasing. So I will say resistance increases as potential difference increases. Now part 2 says explain how the graph in B shows the changes you have described in C part 1. So I have mentioned in previous part that the resistance is increasing. Now they're asking me, why did I answer that? How does the graph show that information? Well, we just discussed it, that it's the gradient of the graph which basically tells me whether the resistance is decreasing or increases. So I would write for a VI, or for an, sorry, I should write for an IV graph where the current is on the y-axis and the potential difference is on the x-axis, gradient is inversely proportional to resistance. So if gradient is decreasing, then resistance is increasing. So that is our answer, right? So now let's move on to question number 4, which is from May-June 2013, and now we have another current versus voltage graph, and this time this is given for a length of the wire. And as I just mentioned in the previous question, there were 3 things for which you need to remember the shapes of the graph. And for a metal wire, you must remember that the graph is a straight line passing through 0, 0, which basically proves that current is proportional to the voltage, which is what? This is a law that you have studied. It is called Ohm's law. So all of the things that we have studied in this chapter are coming together. Now if you look at the graph, it's a straight line and it passes through 0, 0, and always whenever you get this kind of graph, look at the axes first. What is on the y-axis and what is on the x-axis? Sometimes they like to change this around. Sometimes voltage is on the y-axis and current is on the x-axis. So make sure if that happens, you have noticed it. Now they say the wire obeys Ohm's law. State Ohm's law in words. Well, Ohm's law is pretty straightforward. So it is the current is directly proportional to potential difference, but there is a condition, there is a limitation, and that limitation is that the temperature must be constant. So we would say provided that the temperature is constant. Now in part B we have to calculate the resistance of the metal wire. Now what is resistance? It is V over I, and both of these values are available from the graph. Let's take a look. And since the gradient of this graph is constant, the resistance is also constant throughout. We don't have to find the resistance at a specific value. You can just pick any value that you like. So for example, I'd like to pick this point that I've just highlighted. Now at this point I can clearly see that the value of the voltage is 4 and the value of the current is 0.2. So what I'll do is 4 divided by 0.2, and that should give me 20 ohms. Right. Now we have a new wire, so we have a different wire which is made out of the same metal, so resistivity is the same and they have the same length. So far there is nothing different between the two wires. They are the same material and they have the same length, but the area is half that of the original wire. So if the area of the original wire was A, the area of our new wire is actually A upon 2. It is half of the original area. So they are asking for the resistance of the new wire. Well, it's pretty simple. Resistance is inversely proportional to area. And what do you mean when you say two things are inversely proportional? It basically means that if one thing is reduced to half of its value, the other thing is going to be multiplied by 2. If something is divided by 3, if area is divided by 3, the resistance is going to be multiplied by 3. If area is divided by 10, the resistance is going to increase 10 times. It's that simple. So right now the area has been reduced by 2, right? Area has been divided by 2. Therefore the original value of R must be multiplied by 2, which basically means that 20 ohms was the original value. So if you multiply that by 2, what you get is 40 ohms. Pretty straightforward. Area was halved, so the resistance is doubled. Now on figure 6.1, draw a line to show how the current varies with PD for the new wire. So now they basically want us to sketch the graph for this new wire whose resistance is double that of the previous wire. And you basically have to think of it this way. Resistance is the ratio of voltage and current, right? It's V over I. So for each value of V, the current is now going to be half of the previous one. Why? Because the resistance is doubled, so the current does not increase as much. Or you can simply remember the fact that gradient is inversely proportional to resistance. So if resistance of something is being doubled, the gradient should be actually half. So what would the new line look like? Well, at each point on this graph, the value of the current will actually be reduced to half. So if the current at 2 volts was 0.1, for the new wire it would be just 0.05. If at 4 volts the current was 0.2 for the previous wire, for the new wire it would only be 0.1. And at 5 volts, let's say, if the current for the previous wire was 0.25, so for the new wire it would be around somewhere here, which is 0.125. So I just need to draw the same straight line because it's still a metal wire, so the line has to be straight, but only the gradient will be just half as steep as the previous one. So this is the one for the new wire, right? Let's move on. Let's do question number 5. Now we have a torch that contains a filament lamp and which is connected to a battery, and the battery contains 4 1.5 cells in series. Alright, so we have 4 1.5 cells in series, keep that in mind. And again we do have a current versus potential difference graph, and this one is drawn for a lamp, and you can see the shape, it curves and its gradient decreases as we have seen before. Now they're asking what is meant by potential difference. For all the definitions, it is required that you memorize them before the exam. You should not rely on just the concept to write down the definition, but because if you get any technical word wrong, you're going to lose your marks in the exam. So always make a habit of memorizing the definition as well as understanding them. No one is saying that you should not understand the definitions, you should definitely understand their meanings, but from an exam point of view, it's very important that you memorize them, so you don't lose those marks which are basically available for free. So what is meant by potential difference? It is work done per unit charge to drive it across the lamp, because specifically they were asking what is meant by potential difference across the lamp. So that's why we mentioned the lamps, although we don't need to. Work done per unit charge should be enough. So they're saying the graph basically shows the current is not proportional to PD. How does it show this? Well, whenever two things are proportional, directly proportional, their graph actually looks like a straight line that passes through 0, 0. This graph, however, is not a straight line. So basically we can mention that the graph is not a straight line. That's why it shows that the current and the voltage are not directly proportional. It is not a straight line. Alright, let's move. Suggest why the current is not proportional to PD. So in a lamp, you are actually supposed to understand why is the current not proportional to PD. Well, that happens because the resistance of the filament increases. And why does it increase? Because it gets hot. The temperature increases, which causes the atoms to vibrate in the metal, and this makes it harder for the free electrons to flow through the metal, which basically increases the resistance. So let's keep moving. The question is still not finished. We do have a few other parts to go. So now they're saying the lamp is at normal brightness. Remember, whenever they are mentioning normal brightness, then you should go and look for the labeled values on the lamp. Right, so now they're saying at normal brightness there is a 6 volts potential difference across the lamp. Use figure 1.1 to find the current. So they've basically given you complete instructions on how you can find the answer for this question. You've been given the potential difference and you just need to find the current from the figure 11.1, which is the graph. So let's go back to the graph, and all you have to do is use the value of the potential difference from the graph, right? This is the value of the potential difference, and at this value all you need to do is find the value of the current, and you can see that the value of current at this point is 350 milliamperes. It's very important that you look at the units that are given on the graph. This is not amperes, this is milliamperes. So we're gonna say 350 milliamperes, and you can write this as your answer. You can write this in your answer space, but what I like to do is give my answer in SI units. So I will just convert it into amperes, and when you convert it into amperes, you just have to divide it by 1000. So 350 divided by 1000 is 0.35 amperes. So that is what I'm going to write, 0.35 amperes. Now we have to calculate the charge that passes the lamp in 2 hours. How do you calculate the charge? Well, the charge and the current are related by this formula, current multiplied by time. But it is important that the time is in seconds. If the time is in hours or minutes or whatever, you have to convert it to seconds, otherwise your answer is useless. And the current should be in amperes, so it's good that we have already converted the current in amperes. So that would be 0.35 multiplied by the time, and the time can be converted into seconds by 2 hours have 60 minutes, so I'll multiply it by 60, and and each minute has 60 seconds. So if I make this calculation, I should get, well, let me make that calculation. So 0.35 multiplied by 2 hours multiplied by 60 minutes multiplied by 60 seconds, and that should give us 2520. So that would be our charge, 2520. Now what is the unit of charge? Many students tend to forget the unit of charge because you are not given a separate definition for it, or there are not many questions that ask about charge sometimes, so students tend to ignore this quantity and they forget the unit. But the unit of charge is coulombs, which is given by C. Now the battery in the torch is able to keep the lamp lit for 2 hours, so calculate the energy stored in the battery. Well, if there is a certain amount of energy stored in the battery, that is the amount of work that can be done by the battery. So how do you find the work done by the battery? Well, work done will be voltage of the battery, the EMF of the battery, times the charge that is flowing through the circuit. So the voltage of the battery, if you remember, was 6.0 volts, and the charge is what we have just found in the previous part. So if you multiply these two together, we should get our answer. So let's check that again, and if I multiply this answer by 6, I should get 15210. So my answer is 15210, and since this is energy or work done, the unit must be joules. So the battery converts this amount of joules from chemical to electrical energy. Explain why your value is only an estimate. Well, because the battery has internal resistance, or some of the energy is also lost as heat. So not all the energy of the battery is going to be provided to the torch. Some of it is going to get wasted in the form of heat as well inside the battery, right? Because the battery also heats up from its own resistance. So you will say some of the energy is dissipated. By dissipated, I just simply mean that the energy is spread out or lost as heat in the battery. You have to mention that this energy that is being wasted inside the battery. You can't say it is wasted as heat in the torch, because then you would be saying that torch is getting the energy, and that wouldn't make this answer correct. Suggest and explain an advantage of using two cells in parallel rather than a single cell. Now in this part, we can write down our answer just as we did in the previous question, but now you also have to explain what is the reason behind that advantage. So you can't just say cells last longer. What you would say is cells last longer, but you have to give the reason for it as well. So the reason is because the current flowing through each cell is smaller. Let's keep moving. Now there is another torch that contains an LED instead of a lamp. So there is no lamp, there is actually an LED in this one. It uses 4 cells, some in series and some in parallel. But whatever the combination of the cells, the PD across the LED should be 3 volts. So how can you draw a diagram? You have to draw a circuit diagram showing 4 cells in their combination. You have to show a switch and you have to show an LED. So you should remember that the symbol of the LED looks like this. This is our LED, and we can make our switch here. That could be our switch. And now in this space we need to make our cell combination. So what should be the combination of the cells? Think about it. Right. So if you have 4 cells in series, that would give you an EMF of 6 volts. We don't want that. If you have all the 1.54 cells in parallel, that would give you an EMF of 1.5 volts. We don't want that as well. But since we have 4 cells, what we can do is we could have 2 of them in parallel. So that would give you an EMF of 1.5, and then you can have 2 more in parallel, right? You can have 2 more in parallel like this. So this combination gives you 1.5 and this combination gives you 1.5, and since these are in series, together they will give you 3 volts. So this is what I'm going to make here. 1 cell, 2 cells, both in parallel. I have to make sure that my symbols are neat and clean and proper. Make sure all of them are facing in the same direction, otherwise your diagram would be technically wrong. So now this diagram is complete. We wanted to draw 4 cells, that is done. We wanted to draw a switch, that is also done, and we have also shown an LED. So that basically concludes this question. Let's move on to the next question, which is question number 6. And again we have that same diagram which we saw in one of the previous questions. We saw that in this question. Now this diagram is essentially the same. There we had a bulb, but this time around we have a resistor under testing, but the experiment is the same. We have the variable resistor for our adjustments. Now describe how the student uses the apparatus to obtain a range of ammeter and voltmeter reading. How can you get multiple readings from the voltmeter and ammeter? Well, what you need is to adjust the value of this variable resistor. As you adjust its resistance, the readings on the ammeter and the voltmeter will change automatically. So he needs to adjust the resistance of the variable resistor. Alright, now the student obtains a bunch of reading, and here are the readings of voltage and current given, and the voltage readings are in volts and the current readings are in milliamperes. Take care with the units because you might need to use them later on. Now they want us to state Ohm's law. We have already done that, so I'm not going to do that again. But yes, this question is pretty interesting. Using the results in the table, you have to show that it obeys Ohm's law. Now there are many ways to show whether two quantities obeys Ohm's law or not. Basically, what was Ohm's law? Let's first remind ourselves that Ohm's law was that current is proportional to voltage. Now whenever two quantities are proportional, there are multiple ways to show that. One of the ways is that they make a graph which is a straight line and it passes through 0, 0. Right now we don't have a graph, so we can't do that. Now when you have a data given, the other way to show that is whenever the two quantities are directly proportional, what you do is you divide them. You divide the two quantities. So you can divide the current and the voltage, or you can divide the voltage with the current. What you will get is from each reading, when you divide them together, the ratio that you will get will be a constant. So when I divide this quantity with this quantity, and then this one with this one, and then this one with this one, every time I'm going to get the same result, or roughly the same result, which basically will prove that the resistor obeys Ohm's law. So let's do that. What I'll do is I'll divide 320 by 7.6, and then I'll divide 220 by 5.2, and then I'll divide 100 by 2.4. So let's divide each of them. If I divide 100 by 2.4, let's try that. So if I divide 100 by 2.4, I should get 41.7. This is the reading that I'm getting, roughly 41.7. Let's do 220 by 5.2. Let's try that one. So 220 by 5.2, and that also gives us close to that reading. We're not very far off, but we are close enough. 42.3. So we are getting 42.3. Let's do the last one. 320 over 7.6. So 320 divided by 7.6, and that also gives us roughly the same reading, which is 42.1. So you can see that the readings are very close to each other. They are within the margin of error. They are very close to each other. So this is what we are going to write. You're going to show those calculations here. You're going to say 320 over 7.6 was 42.1. You're going to show the other two calculations here in this area, right? Do not be afraid to show your calculations. This is exactly what they want to show. They want to see your calculations. So when you show your calculations, you will then mention, since the ratio of I and V is a constant, the resistor obeys Ohm's law. And whatever conductor obeys Ohm's law is called an ohmic conductor, and conductors that do not obey Ohm's law are called non-ohmic conductors. For example, a filament lamp is a non-ohmic conductor. So now we are given a bunch of available ranges for the ammeter, and they're asking how can the student make best use of these ranges in his investigation. Well, we need to remind ourselves that his readings for the ammeter for the current were 320, 220 and 100. So let's write down his three readings: 320, 220 and 100, and all of them were in milliamperes. So what are his best chances of getting the answer? Well, if you convert all of them to amperes, you will get 0.32 amperes, you would get 0.22 amperes, and you will get 0.1 amperes. The problem is, if you use this range, it would be too large for these readings, because if I have an ammeter, let's say an analog one, and here it says 0 and here it says 10, what would be the deflection that I will see when there's a current of 0.3 ampere or 0.2 ampere? The deflection will hardly move from 0. There will be a very small deflection because the range is too large. So this range is not a good idea. Well, then what can I do? This is I don't have any other choice, because the problem is that the values of the currents that are available to us, are bigger than all of these above ranges, right? In normal situation, this range would not have been a very good idea. But if you look at the other ranges, the maximum value that they go to is 200 milliamperes, and two of our values are bigger than that. So it's impossible to use the other ranges for the first two values. So for first two readings, his best choice is to go with 0 to 10 amperes. For the first two readings, the range should be 0 to 10 ampere. For the last reading, however, you can think about which range you can use. The reading is 100 milliamperes, so it would give you a good 50% deflection with the second range. All the others are smaller than 100, so they cannot be used. So for the last one, the best choice would be this range. So for the last reading, the range must be 0 to 200 milliamperes. Alright, so now we are on to the second last question, and in this one there is an electrical engineer that measures the potential difference across the length of a metal wire and the current in the wire, and he does this for different values of the current. Now we have to draw a label diagram, and we have to show how he does this. Well, so let's suppose this is the metal wire that he has to perform the experiment on. What do you need in order to measure the PD across it? You need a voltmeter to connect parallel to it. What do you need to measure the current through it? Well, in order to measure the current, you need an ammeter through it. Then you need definitely a cell or a power supply. So we have the cell. You need a switch to switch the circuit on and off. And how will you adjust the values of the voltage across the battery or across the wire? As we have seen in previous questions as well, that you would need a variable resistor. So with the variable resistors, you will make those adjustments, and this wire is basically under test, just like we saw with the lamp and the resistor in previous questions. So describe how the circuit is used. We'll just say the variable resistor is adjusted to get different values of PD and current. And how do you measure the current and the PD? The PD is measured from the voltmeter, and the current is measured from the ammeter. And that's it. State the equation that defines resistance. Well, resistance is quite simply potential difference divided by current. That's it. All right. The engineer performs the experiment and notices that the potential difference across the wire is directly proportional to current. So the wire does obey Ohm's law, right? He calculates the resistance of the wire and plots a graph of resistance against current. Now, on first thought, you might say, well, you have to sketch the graph. If it obeys Ohm's law, then it should be a straight line. The only problem is that you would not be reading the question carefully enough. They do not want us to graph current versus voltage. They want us to graph resistance versus circuit. Now, if something obeys Ohm's law, which means that the ratio of the voltage and the current is constant. So what is the ratio of voltage and current? That is this. And what is this equal to? This is equals to resistance. So whatever is this wire, if it is obeying Ohm's law, then the resistance must be constant. So no matter what you do, you increase the current, you decrease the current, you increase or decrease the voltage, the resistance must remain constant. And if the resistance remains constant, then obviously you should get a line which is perfectly straight and flat. The value of resistance will not increase or decrease at all. So that would be your answer. On to the last question, question number 8. This is from 2014, October, November. So in figure 7.1, we have an ammeter, a 6 ohm resistor, and we have a piece of wire, and we have three 1.5 volt cells which are connected in parallel. Everything you can see in the diagram clearly. Now they want us to state one advantage of using cells in parallel rather than using a single cell. We have answered these questions 2 times previously, so we can just write it again. Cells last longer. We don't need to write the reason here because it just says state as the command word. You could have also written, you don't need to write 2 because you wouldn't get any extra marks for it. But if you were to write the other reason, that would be if one cell stops working, the others keep working and the circuit is basically not affected. Now we need to state the potential difference between points P and Q. All right. What would be the potential difference between these points, point P and point Q? So essentially they're asking us what would be the potential difference across this entire circuit. The potential difference across this entire circuit should actually be equal to the EMF of the cells. And what would be the EMF of the cells which are all in parallel to each other? Well, we have studied that if they are all parallel to each other, then the EMF should be just equal to the value of one cell, which is simply 1.5 volts. So 1.5 volts is the EMF of these cells, and that would be the potential difference from this point of the circuit to this point of the circuit. Alright, now the ammeter reading reads 0.075 amperes. So this is the value of the current, right? And where is the ammeter? Here is the ammeter. So the current passing through this point is 0.075 amperes. And they're asking you calculate the resistance of the wire only. So we need to calculate the resistance of the wire. Let's see. What do you need to calculate the resistance of the wire? Well, the formula for resistance is V over I. Do we know the potential difference across the wire? That is the point. No, we don't. We don't know the potential difference across just this part of the circuit. If we don't know that, we can't directly use this formula right now. So we can't find the resistance of the wire directly in this question, and this question should take you a few steps because you can see that there are 3 marks in this question, so you will have to work a little hard. So the first thing that we can do is we can find the combined resistance, the total resistance of the resistor and the metal wire together, the entire circuit. So if we know that the combined voltage of the entire circuit, the potential difference between P and Q is 1.5 volts, and the current that passes through the entire circuit is 0.075, then I can find the resistance, the total resistance. This is not just the resistance of the wire, this is the total resistance of the circuit. So 1.5 divided by 0.075. 1.5 divided by 0.075, and when I do that, I get 20 as my answer. So 20 ohms is the total resistance. So now what would be the resistance of the wire only? If the resistance of this wire is X and the resistance of the resistor is 6, then 6 plus X should be 20. That means I just need to subtract, in order to find X, I just need to subtract 6 from 20, and that should give me 14 ohms. So 14 ohms should be the resistance of the wire. So there were a couple of steps involved, but it wasn't that hard. Now the temperature of the wire increases. State and explain the effect of the temperature on the ammeter reading. Well, when temperature increases, what is affected? The first thing that will be affected will be the resistance. So when temperature increases, resistance increases of the wire. If the resistance is increasing, so the current must decrease. The ammeter reading is basically your current, right? So we are going to say that the ammeter reading is going to decrease, and this is basically our answer. So that's it for this video, and hopefully I'll see you in